Algebra 2 Honors 10.1 Day 2 notes. We're looking at continuing with finding probabilities, and today we're going to look at experimental probabilities, just a couple of short, quick examples. And experimental probability is based on repeated trials, so you're actually, rolling the die and seeing what happens and counting up the number of times that you roll the die, and each trial in which a favorable outcome occurs is called a success. So if I'm looking at how many times does a 2 show up, and I throw the dice 10 times and the 2 shows up 4 times, the experimental probability is 4 out of 10 or 2/5, 40%. So experimental is number of successes over number of trials. Experimental versus theoretical. And so in this example 5, a spinner has 5 sections colored red, green, blue, yellow, and purple. Each section of the spinner has the same area. That means, each of those colors has 1 out of 5 possibilities. They're equally likely. And then the table shows the results of 50 spins. So someone sat and did it spinning. Is it going to hit each one the same amount of times since there's the same amount of area? No, it's not going to work that way. Experimental probability only starts reaching theoretical probability if you do a lot of trials. If I did 1,000,000 spins, then I would hope that I'm getting closer to hitting each color 20% of the time. So anyway, so right here, we have the experimental probability, which is how many times out of 50 each of these colors were hit. So experimental. And I'm just going to probability of a red, probability of green, probability of blue, probability of yellow, probability of, they were kind to make these all start with different letters. And the experimental is you had red 5 out of 50, which is 1/10 or 0.1. Green was 20 out of 50, which is 2/5. Blue was 3 out of 50. And yellow was 10 out of 50, which is a 1/5. And probability of purple was 12 out of 50, which is 6 out of 25. For which color is the experimental probability of stopping on the color the same as the theoretical? But all theoretical probability for each color is the same because they have equal area. And you have 5 colors, so it's 1 out of 5. So notice that the yellow has the same experimental probability as the theoretical. That might not have happened at all, but in this case it did. So example 6, in a survey of 2184 adults ages 18 and over, they found that 1328 of them have at least one pet. The types of pets these adults have are shown in the figure. What is the probability that a pet-owning adult chosen at random has a dog? Well, this 2184 was the total number surveyed, but only 1328 of them had a pet. And it said, we're only interested in the pet owning, so this is going to be the total in my denominator. And this is experimental probability. And so the probability that it is a dog, and given that it's pet owning, is in that table there are 916 adults that have pets, that have dogs, out of there were 1328 that had at least one pet. And that's pretty much it. You can reduce that to 29 over 332, which is approximately 0.690 or approximately 69%. that's it.